Chapter 5: The Industrial Revolution and the Loom. The human foot, viewed purely as a mechanical structure, is an evolutionary marvel of 26 bones, 33 joints, and more than 100 muscles, tendons, and ligaments. Viewed from the perspective of everyday historical survival, however, the human foot is a profoundly needy, sweaty, and blister-prone appendage. It swells under the weight of bipedal locomotion. It perspires profusely. And most critically for the history of human progress, it develops highly specific, agonizing frictional complaints when rubbed against stiff leather or hard earth. Long before the advent of the modern, ergonomically engineered shoe, human beings realized that walking across the unforgiving, jagged crust of the planet required armor. And that armor, in turn, required a soft, yielding buffer. Without a forgiving layer of textiles inserted between the delicate epidermis and the harsh exterior of a boot, the foot rapidly becomes a horrifying landscape of ruptured blisters, hardened calluses, and weeping, infected sores. The biological solution to this friction problem, for centuries, was the stocking. But before the stocking could be mass-produced, it had to be knitted. And hand knitting, while practically a miracle of minimal equipment requiring nothing more than 2 pointed sticks and a continuous string of spun fleece, is outrageously, punishingly slow. To truly grasp the sheer temporal cost of keeping 16th-century feet comfortable and blister-free, one must deeply examine the biomechanics of hand knitting. It is a process of creating a continuous sheet of fabric from a single strand of yarn by repeatedly pulling tiny loops through other tiny loops. The human hands, with their 27 bones, highly articulated joints, and incredibly sensitive nerve endings, are uniquely, almost perfectly suited to this highly specific task. The fingers grasp the rigid needles, apply precise tension to the fibrous yarn, insert the needle point through a tiny opening, catch the thread, pull it through, and drop the old loop to secure the new one. It is a quiet, rhythmic, meditative fireside activity. It is also an activity that requires intense, unrelenting focus and endless, tedious hours to produce a single pair of fitted, functional garments. For hundreds of years, the creation of hosiery, hosiery, was the absolute domain of highly skilled artisans and remarkably busy housewives, people who spent their waking days mechanically turning the sheared fleece of a sheep into the exact anatomical shape of a human lower leg. It was peaceful. It was slow. And then, at the tail end of the 16th century, a lovelorn clergyman decided to completely and permanently obliterate this quiet domestic art. The creepy muse. The humble, often grimy origins of the Industrial Revolution do not actually begin with a roaring, coal-fed steam engine or a sprawling, smoke-belching urban factory. They begin, rather awkwardly, with an unsettling display of romantic obsession in the rural English village of Calverton, located in the sheep-heavy county of Nottinghamshire. The year was 1589, and the man in question was Reverend William Lee, a local curate and alleged clergyman. As the enduring local legend goes, Reverend Lee had fallen profoundly and hopelessly in love with a young woman of the village. The young woman, however, did not return his clerical affections. She was a keen, dedicated knitter, and whenever the eager, lovesick clergyman came to call upon her, she pointedly ignored his sugary talk, keeping her eyes firmly fixed on her clicking wooden needles. Instead of taking the incredibly obvious hint, retreating with his dignity intact, and perhaps writing a melancholic, brooding sonnet like a normal 16th-century suitor, Reverend Lee took a darker, far more mechanical path. His unrequited desire for a wife was rapidly eclipsed by a malevolent, all-consuming determination to spoil her knitting passion forever. He stopped trying to woo her, he simply began to stare at her hands, he watched her endlessly. He did not watch her with the soft, poetic gaze of a romantic, but with the cold, calculating, dissecting eye of an engineer. The listener must imagine this bizarre scene. A grown man sitting in the corner of a 16th-century room, obsessively tracking the micro-movements of a woman's knuckles. He observed exactly how she made the loops. He noted the precise angle at which the needle penetrated the yarn. He measured the tension applied by her index finger. and he began to wonder how he could perfect and replicate that highly specific flesh and bone technique with heavy, unfeeling machinery. He decided, out of pure spite, to build a device that would render the woman's agile hands entirely obsolete. At the time, there were no similar machines from which Lee could draw inspiration. The weaving loom existed, certainly, but weaving is a simple over and under geometric grid. Knitting is a complex series of interlocking, flexible loops. To mechanize this, Lee had to develop the concept completely from scratch, translating the fluid, organic movements of human tendons and ligaments into a rigid, terrifying geometry of wood and metal. After 3 years of obsessive, isolating hard work, he finally succeeded. The invention he unleashed upon the world was called the stocking frame, and it was absolutely terrifying. One must picture the very first stocking frame not as a sleek, miraculous marvel of modern engineering, but as a clanking, finger-pinching, wooden monster. It was a massive, stout wooden frame containing over 2,000 individual, moving parts. To operate this machine, a person did not sit quietly by the warm fire with a ball of yarn in their lap. The frames were incredibly large and required immense physical strength to manipulate, rapidly transforming the delicate, traditionally female art of knitting into an exhaustingly heavy, full-body labor that soon became almost exclusively men's work. The biomechanics of Lee's machine were mind-bogglingly complex for the Tudor era. Instead of using a simple pair of needles to knit a single stitch at a time as a human hand would, Lee's machine utilized a long, horizontal line of specially shaped iron hooks called bearded needles. These low-carbon steel bearded needles had tips that were reflexed, meaning they bent backward, and they could be physically depressed into a hollow groove on the needle shaft to close the loop. The machine operator had to manage a violent, perfectly timed sequence of mechanical movements to prevent the machine from jamming or snapping its needles. First, the heavy needle bar was pushed forward. Then, the weft thread was laid horizontally across the open needles. Next, heavy metal components called jacksinkers descended from above to push the thread down and form the loops. A divider bar then forcefully pushed the thread further down. The jacksinkers then violently yanked the thread directly into the beard of the open needles. A heavy presser bar slammed down from above to close the loops, and the old row of stitches was aggressively drawn off the needle. The entire process was accompanied by a deafening, rhythmic symphony of clanking iron and groaning wood. This was a machine that could easily bite. With its exposed moving parts, heavy descending bars, and hundreds of sharp metal needles, operating the stocking frame meant routinely placing one's soft, vulnerable human hands inside a relentless mechanical jaw. Yet, continually repeating this brutal, clanking cycle produced a perfect, continuous tube of knitted fabric, achieving in mere minutes what took the object of Lee's affection hours to create by hand. He had successfully replicated human dexterity with 2,000 pieces of unfeeling hardware. In a strange, somewhat tragic twist of fate, the sheer magnitude of the invention finally sparked the young woman's interest. But by that point, Lee was so entirely engrossed in his clanking iron monster that he had lost all romantic interest in her. The unrequited love story died in the shadow of the machine, but the first major stage in the mechanization of the global textile industry was born, dripping with oil and clattering with the sound of progress. The Royal Snub. Having successfully conquered the biomechanics of the knit stitch and effectively weaponized his own romantic rejection, William Lee sought his fortune. He moved his massive contraption from the sheep-dotted hills of Calverton to the bustling, politically treacherous streets of London, aiming for the absolute pinnacle of 16th-century venture capital. Queen Elizabeth I, through the powerful intercession of Lord Hunsdon, Hunsdon, a well-connected royal chamberlain, Lee managed to secure an audience with the Queen, hoping to demonstrate his miraculous machine, astound the royal court, and walk away with a highly lucrative royal patent. To fully understand the physical reality and the ultimate failure of this meeting, the listener must deeply examine the highly specific sensory environment of the Tudor court. By the early 1590s, Queen Elizabeth was a woman deeply accustomed to the finest, softest textiles the known world could possibly provide. 16th century sumptuary laws tightly regulated who could wear what based on social class. And as the reigning monarch, Elizabeth was practically swaddled in luxurious tissues, cloth of gold, and imported Spanish silk. Furthermore, she had a particular, well-documented bodily fondness for extremely fine undergarments. She had received her very first pair of gloriously soft, hand-knitted silk stockings as a Christmas gift in 1561 from her silk woman, a Mrs. Montague. The sensory profile of silk is entirely unique. Silk is a natural protein fiber, extruded from the salivary glands of the mulberry silkworm caterpillar. It is smooth, it is breathable, and it glides effortlessly across the human epidermis without catching, snagging, or dragging. It is the ultimate indulgence for the friction-averse foot. William Lee, however, came from an area known almost exclusively for its wool. The very first iteration of his monstrous stocking frame was a relatively crude piece of engineering, featuring only 8 iron needles to the inch. Because the needles were so widely spaced and the mechanism so aggressive, the machine could only process coarse worsted wool. When Lord Hunsdon, Hunz, excitedly presented the Queen with the very first machine-made stocking for her inspection, she reached out to touch a garment that was historically unprecedented, yet fundamentally abrasive. The Queen's visceral reaction was one of pure sensory horror. Handed a coarse, machine-knit wool stocking, her royal sensibilities recoiled. The sensory contrast between her usual imported Spanish silk and Lee's 8-needle-per-inch wool was vast and insulting. Wool of this rough, unprocessed grade is a remarkably scratchy, punishing fiber. Under a microscope, a wool fiber looks like a pinecone. It is covered in tiny, overlapping scales. When pressed against the skin, these microscopic scales catch on the epidermis, causing microscopic friction, relentless itching, and localized chafing. The very idea of encasing the royal calves in such an abrasive, pedestrian material was unthinkable to a woman who wore silk. However, Elizabeth I, demonstrating the sharp political savvy that defined her long reign, did not explicitly tell William Lee that his miraculous invention was simply too itchy for her legs. Instead, she framed her rejection as an act of profound economic mercy. Looking at the clanking machine that threatened to render human hands entirely obsolete, the Queen reportedly fixed Lee with a cold stare and delivered a devastating blow. "Thou aimest high, Master Lee," she said. "Consider thou what the invention could do to my poor subjects. It would assuredly bring to them ruin by depriving them of employment, thus making them beggars." She claimed to the court that she had far too much love for her poor people, who obtained their daily bread by the quiet employment of hand-knitting, to give her money to forward an invention that would ruin them. It is a fascinating, almost absurd historical irony. A reigning monarch effectively halted the momentum of the Industrial Revolution to ostensibly protect the hand-knitting guilds, but she also left the door open just a tiny, tantalizing crack. She noted that if Master Lee had made a machine capable of knitting soft silk stockings, she might have been somewhat justified in granting him a patent. One has to seriously wonder, looking at the historical record, how much of her economic protectionism was genuinely driven by a fear of artisan unemployment, and how much was driven by the visceral, bodily dread of itchy ankles. Determined, and perhaps slightly maddened, William Lee went back to his workshop and spent years meticulously building an improved, far more delicate machine that increased the needle density from 8 to a staggering 20 needles per inch. By 1598, he had successfully engineered a frame that could handle the delicate, slippery, highly prized threads of fine silk. He triumphantly returned to the crown, only to be rejected again, this time by Elizabeth's successor, King James I Dejected, denied by 2 successive monarchs, and utterly unable to secure his intellectual property in his home country. Lee packed up his iron monsters and moved his entire operation across the English Channel to France. He found brief, shining patronage under the Huguenot, King Henry IV, and successfully began manufacturing fine stockings in Rouen, Rouerchen. However, following the sudden assassination of the French king, the political climate abruptly changed, and Lee's fortunes collapsed entirely. The obsessive man who successfully mechanized the complex biomechanics of the human hand died penniless, ignored, and deeply distressed in Paris, Paris, around the year 1614. The deafening shift. William Lee died a profound commercial failure, but his clanking iron monster refused to stay buried. The technology was simply too efficient to die with its creator. Following Lee's lonely death in France, his surviving workers, assistants, and brother hauled the heavy machines back across the Channel to England. There, an apprentice named John Ashton, made a crucial, incredibly specific biomechanical improvement to the machine by adding a small mechanism known as a divider. This relatively small metal tweak smoothed out the operation of the sinkers, and suddenly, the stocking frame was a viable, economically unstoppable force. For a time, framework knitting remained a cottage industry. Massive wooden frames took up the entire living rooms of rural families, operated by the sheer, grueling muscle power of men who worked the heavy pedals, while women and children sat nearby, engaged in finishing the knitted garments and winding the yarn. It was hard work, but it was still situated within the home. But as the 18th century bled into the 19th, the global demand for cheaper, mass-produced cotton stockings exploded, and the physical reality of textile production underwent a terrifying, monumental transformation. The frames were continually adapted and improved, but they also became far too large and far too expensive for individual families to own. Wealthy investors, seeing the incredible profit margins in mass-produced clothing, bought the machines by the dozen, grouped them together in massive, multi-story buildings, and attached them to external, relentless power sources like water wheels and towering steam engines. The Industrial Revolution had truly arrived, and the very first thing the listener must understand about it is that it was devastatingly, violently loud. To step from the quiet, rhythmic clicking of wooden needles by a rural hearthside into an early 19th century textile mill was to step into a completely different sensory dimension. The transition was a bone-rattling, deafening shift that assaulted the human nervous system. These early mills were not just workplaces. They were giant, steam-powered woodchippers that happened to occasionally produce fabric. The quiet art of knitting and weaving was now centralized in massive, cavernous rooms packed with hundreds of heavy machines, all violently drawing power from a singular, terrifying system of wildly spinning overhead leather belts, massive gears, and groaning pulleys. The bodily toll on the humans operating these new machines was catastrophic. In the relentless pursuit of cheap hosiery and textiles, the fragile worker's body was treated as merely another, somewhat more disposable, gear in the system. The noise alone was a constant physical assault. The aggressive, unceasing clatter of hundreds of iron frames, metal shuttles, and wooden spindles slamming back and forth at hundreds of times per minute made verbal conversation absolutely impossible. The sheer volume of the mechanical noise far exceeded any modern occupational safety limits. The sound waves violently bombarded the delicate hair cells in the human cochlea, aggressively destroying the worker's hearing and causing permanent, profound deafness. Workers trapped in this auditory hellscape had to quickly develop their own rudimentary sign languages and learn to read lips just to communicate basic survival information during a brutal 12-hour shift. But permanent deafness was arguably the least of the physical perils on the factory floor. The early mill was a landscape of exposed, fast-moving parts hungering for soft human flesh. The entire mill line featured hundreds of high-tension belts, spinning spindles, and flying metal shuttles that could easily snag a loose sleeve, a wide skirt, or a stray lock of hair. A single moment of inattention, a simple slip of the foot, resulted in flesh being instantly pulled into the ironworks. Fingers were routinely pinched off, crushed in the gears, or mangled beyond repair. The power transmission system was perhaps the most lethal component. Massive leather belts, transmitting power at terrifying speeds above the workers' heads, would occasionally fatigue and snap under the immense tension. When a heavy, high-speed belt broke, it lashed out across the room with the force of a bullwhip. It was capable of striking a worker so hard it could knock them unconscious, tear the skin from their bones, or kill them instantly. Workers lived in constant, low-level terror of these overhead belts. One wrong move while cleaning a machine with a brush could result in the brush catching the belt, violently yanking an arm into the pulleys, skinning the limb, and snapping the bones like dry twigs. One historical account describes a worker whose shirt caught in an overhead belt. The mechanism violently threw him to the ceiling of the mill, busting his brains out against the heavy wooden beams. The physical danger extended even to the very air the workers breathed. The processing of raw cotton for the knitting frames filled the stagnant, humid air of the locked factory floor with millions of microscopic particles of lint and cotton dust. Every single breath drew this abrasive, fibrous particulate matter deep into the human respiratory system. The dust accumulated in the lungs, irritating the delicate alveolar sacs and triggering massive, chronic inflammatory responses. This debilitating respiratory condition, known clinically as bisonosis, was commonly and morbidly referred to by the textile workers as the kiss of death, or simply brown lung disease. Workers coughed endlessly, their lungs physically plugging up with wet cotton dust over the course of the work week. Some workers resorted to chewing heavy, massive wads of tobacco, keeping it in their mouths all day purely in the desperate hope that the sticky saliva and the physical wad might catch some of the deadly dust before it strangled them. Perhaps most horrifying of all to the modern listener was the deliberate integration of small children into this mechanical nightmare. Due to their small physical size and incredibly cheap labor cost, children as young as 8 years old, known in the mills as doffers, were employed to do the most dangerous maintenance work. Their job was to dart quickly between the violently moving machinery to replace full bobbins of thread with empty ones, or to fix tangled textile lines. They were frequently forced to climb directly atop the heavy iron frames, reaching their tiny hands into tight places adults could not fit, while the massive machines continued to run at full, deafening speed. Exhausted, severely underfed, and chronically sleep-deprived from 12-hour shifts that began before dawn, these children routinely fell victim to the snapping jaws of the looms and frames, losing fingers, limbs, and sometimes their lives to the crushing iron. The physical deformities inflicted by this labor became so common that 19th-century medical observers could easily identify a textile worker walking down the street. Observers noted a general bowing of the leg bones, severe spinal flexures from constantly bending over low frames, and a sprawling, awkwardly wide action of the legs among the factory hands. The human body, forced to perform repetitive, unnatural motions for 14 hours a day, was literally being warped and remodeled to fit the geometry of the machine. It begs a profound, almost disturbing question. Why did humanity collectively endure this visceral, bone-crushing horror? What was the output that justified feeding generations of humans into these deafening, limb-tearing mills? The answer, surprisingly, is deeply intimate, surprisingly hygienic, and completely transformed human survival. The brutal factories were churning out the underwear revolution. The underwear revolution. Before the mass mechanization of textiles, the state of everyday human hygiene for the average working person was grim. It was an era of intense, unwashed bodily smells and relentless itching. Through the Middle Ages and well into the early modern period, the clothing of the common people was highly valuable, painstakingly made by hand, and incredibly difficult to clean. Thick wool outer garments, heavy woven skirts, and stiff trousers were rarely, if ever, fully washed. To wash heavy wool is to risk shrinking and felting it, destroying its structure. Furthermore, the sheer manual labor required to haul gallons of water, heat it over a wood fire, and scrub heavy, sodden cloth was prohibitive for someone working daylight to dusk. Consequently, a working-class person might wear the exact same unwashed outer garments every single day for months, or even years on end. This created a terrifying biological crisis directly on the surface of the human skin. The human body is a leaky, oily, constantly shedding organism. It produces sweat, sebum, dead skin cells, and various other fluids. When trapped beneath heavy, unwashed, highly insulating clothing, this organic debris ferments and putrefies, creating a highly specific, warm, humid microclimate that is absolutely ideal for parasites. Enter the primary villain of historical hygiene, Pediculus humanus corporis, Pudiculaus hywameanus corporis, commonly known as the human body louse. The body louse is a creature of exquisite, horrifying opportunism. Unlike the head louse, which navigates the hair shaft, the body louse does not live on the human body itself. It has evolved specifically to live deep within the seams and folds of human clothing, venturing out onto the bare, warm skin only to feed on human blood. A person wearing layers of unwashed, hand-woven wool was essentially providing a luxury, temperature-controlled condominium complex for thousands of blood-sucking parasites. The infestation of body lice was not merely an itchy, embarrassing nuisance. It was a deadly vector for disease. The feces of the body louse carry epidemic typhus, a horrific disease that routinely wiped out massive armies, decimated cramped urban populations, and caused agonizing fevers. Furthermore, the constant, relentless feeding of the lice caused severe skin irritation, which led to intense scratching, which in turn opened the skin to secondary, potentially fatal bacterial infections. The historical crotch and armpit were veritable war zones of biting insects and bacterial blooms. The only way to effectively kill the body louse and its firmly attached eggs is to boil the clothing it lives in. But boiling expensive, delicate, hand-woven wool outerwear was impossible without destroying the garment. The biological solution to this microscopic warfare was the creation of a sacrificial layer. Humans desperately needed a cheap, relatively fitted, easily washable barrier that could be worn directly against the skin. This layer would absorb the bodily fluids, catch the shedding skin cells, and provide a washable shield to protect the expensive outer garments from the dirty body, and the vulnerable body from the rough, louse-infested outer garments. This is exactly what the clanking, terrifying machines of the Industrial Revolution provided. By mechanizing the knitting process, the descendants of Reverend William Lee's stocking frame drastically lowered the cost of producing fitted, flexible fabrics. Suddenly, the democratization of hosiery and base layers was possible. The working class could finally afford what was once the exclusive luxury of monarchs: multiple sets of undergarments. The introduction of incredibly cheap, machine-made cotton and wool drawers, chemises, and undershirts radically altered everyday survival. Cotton, unlike wool, is a remarkably durable plant fiber that can be subjected to the violent, boiling temperatures required to effectively launder clothing and kill lice and their eggs. By the mid-19th century, a factory worker or farmer could actually own several pairs of machine-knit underpants or union suits. They could wear one pair directly against the skin, allowing the cotton to absorb the daily sweat and grime, while the other pair was thrown into a massive iron pot of aggressively boiling water and harsh lye soap. This simple, revolutionary rotation of cheap base layers broke the life cycle of the body louse, drastically reducing the transmission of typhus and preventing endless, miserable skin infections. Furthermore, the physical comfort provided by these mass-produced base layers was absolutely revolutionary. Woven fabric is stiff, it only stretches on the bias. Knitted fabric, however, possesses an inherent mechanical stretch. The interlocking loops invented by ancient hand knitters and violently replicated by William Lee's machine allow the fabric to bend, expand, and move perfectly in tandem with the human joints. Prior to cheap knitted undergarments, laborers had to endure the constant, abrasive friction of heavy woven wool or stiff linen, rubbing directly against the sensitive skin of the inner thighs, the armpits, and the waist. The severe chafing experienced by a 19th century dockworker or farmer before the advent of fitted underdrawers is difficult to overstate. A long day of physical labor without underwear resulted in raw, bleeding thighs. Machine-knit base layers provided a soft, protective, incredibly flexible layer that minimized this friction, kept the body significantly warmer in winter by trapping a layer of insulating air tightly against the skin, and actively wicking moisture away during intense labor. The split-crotch drawers of the Victorian era, essentially the direct ancestors of modern women's underwear, allowed women to navigate the architectural complexities of massive hoop skirts, heavy crinolines, and multiple petticoats without having to completely disrobe to use the privy, vastly improving daily comfort and sanitation. For men, the knitted union suit, or long johns, initiated by the later dress reform movements, provided full-body coverage that acted as a breathable, washable second skin. In looking back at the deafening mills, the flying iron shuttles, the snapping leather belts, and the horrifying industrial accidents, one finds a profound, almost dizzying historical paradox. The relentless machines that mangled the limbs and destroyed the lungs of the factory workers were simultaneously producing the very garments that healed, protected, and comforted the bodies of the general public. The mass production of stockings and undergarments elevated baseline human hygiene from a state of lice-ridden, scratching misery to one of relatively clean, gentrified comfort. The entire trajectory of this textile revolution is delightfully, morbidly absurd. It began with a resentful clergyman in Calverton, who was so deeply, romantically annoyed by a woman ignoring him that he built a 2,000-part wooden monster just to knit faster than her. The technology was then temporarily stalled by a highly fashionable queen who found the resulting wool too horribly scratchy for her royal, silk-accustomed legs. It then evolved into a deafening, bone-crushing system of factory machinery that deafened its operators, filled their lungs with dust, and maimed its child workers. And ultimately, after all that noise and blood, it culminated in the glorious, life-saving democratization of cheap, washable underpants. The history of the stocking frame stands as a perfectly weird testament to the visceral nature of human progress. It proves, without a doubt, that a broken heart can lead to a mechanical breakthrough, that sensitive ankles can redirect national economies, and that sometimes the greatest leaps in public health and human survival do not come from a physician's sterile laboratory, but from the ability to quickly and cheaply manufacture a soft, friction-reducing barrier for the human crotch. The quiet, repetitive click of the hand-knitter's needles had been forever silenced by the deafening roar of the machine. But in exchange, humanity was finally granted the physical relief of a warm, fitted, and remarkably cheap pair of socks.